All right, thanks everybody for joining. Super excited to have another brown bag this week. We've got Michael Rossetti, who is going to talk about automated testing in Python. So take it away.
Oh yeah. All right. Hello everyone. So I could see a few of your faces. If everybody could just give me like a wave, I'm gonna do a quick scroll. Are we awake? We're eating. Cool. I just scarfed some food too. Thanks for being with me today. So I'll give a quick intro and to myself, and then I'll talk about what lecture I have planned and how it's structured. So my name is Mike Rossetti, and I'm a data scientist and software developer. And I've been teaching Python programming recently at a few universities, and I really like teaching, and so hoping to teach at the Lambda school. And so here we go. This is my lecture. So I was asked to pick a topic to talk about, and the topic that I chose today is automated testing and more generally quality control, but specifically automated testing and using the PyTest package in Python. So we had a poll taken, I guess, in Slack, and what I'm understanding is that your familiarity in general with automated testing, about I was told around 50 to 70% of you answered not familiar at all, and about 30% said somewhat. So I think I picked a lecture topic that can be helpful for you, at least in the sense that it might be some high level conceptual awareness that you might gain. And if you want to start testing all of your programs tomorrow, then I think that's the hope of the lecture. But so before we dive into the lecture, actually, yeah, no, let's dive in. All right. So no, I'll give a quick anecdote. Okay, so I was working in San Francisco as a data role, and I was writing software to do my data processing and automate all that stuff, like I'm sure a lot of you have done. And I had a code base, and my app worked great, but the software engineers at the company, whenever I heard them talking about my app, all the terms that they were using was technical debt. It was like they were like looking down their noses at me, and I was doing my best, like learning how to program. And I didn't go to undergrad for computer science, so I didn't know about testing. And they were just calling my app technical debt, which I guess means that someone's gonna have to go fix it later or something like that. But it was working anyway. So anyway, that was a few years ago. Since then, I've discovered automated testing on my own, and specifically a workflow called test-driven development, in which we, as software developers or data scientists, write the test either before or during the time when we're actually writing the application code. So tests are just normal software code that accompanies our code and specifies what the desired behavior of our code should do. All right, before diving in anymore, I'd like to share with you an overview of the materials that I've shared that you should have links to, and I'll start diving in. And we'll do some coding live, and hopefully you'll have as much fun as I'm having already. All right, so you can see my screen, I think, and in the background is a repo that I prepared especially for this lecture for you all. So you should have the link. If you, I'd like for you to fork it so that you can. Thanks, 10 of you have forked it so far. I'd like you to fork it so that you can work in this repository and then like have it a copy on your own to refer to or maybe update, and it'll be your copy. So I recommend that you fork it, but even if you just wanted to clone or download, that's fine. All right, so I just need to see more of my own screen here. Ooh. All right. All right, I'll just deal with it. So, sorry.
No worries. If you want, you can zoom
Okay.
out a little bit.
I'll just figure it out. It's fine.
All right.
So, all right. Hey, here's this. Oh no, I'm just gonna. I can't see you, but anyway, I'll just go. Hello. So here's the repo that I shared with you. You'll also notice in this repo, there's links to some notes, high-level conceptual notes, and also some slides. And you can refer to these at any time. Also, if you want at any time to start setting up this repository and downloading it so you could follow along, you could start doing that right now. I've given some instructions here. I don't know if you all use Anaconda for virtual environments or how you're managing your packages, but I use Anaconda, so I gave the Anaconda instructions. But basically, if you've got pip and you're able to install PyTest and some other packages later, that will be fine. And we'll be working with Python 3.7. All right, so I hope that you all are starting to set up this repo, but before we get into it, I'd just like to share quickly with you what you'll expect at those other links. So we've got some slides about software quality control and some written notes. So when I'm teaching programming, I like to give written materials as well because A, I misspeak a lot. And so you could always defer to the written material. That's why I created this repo for you and these notes. But also, so you have a more expanded version of the knowledge. All right, so let's take a quick look in the slides before we continue with the repo. So I said, hey, my lecture topic is automated testing, and why is this even relevant? So I talked about those software developers kind of like calling my code tech debt when it didn't have tests. And but so our goal in implementing tests to accompany our code is essentially to increase the quality of our application. And this is important for business especially and any user-facing applications, because if a user encounters a bug in the app that they're using, that may produce a bad user experience for them, and they may be less likely to use the app, maybe less likely to continue paying for any services that they're paying for. And so the quality of our applications is directly tied to a business's bottom line, in the sense that it is getting revenue from its customers and users who are using the app. So businesses should care and organizations should care about quality control, because ultimately it will lead to more profits, more customer retention, less customer churn, stuff like that. Better user experiences, which can lead to users kind of recommending the app to others. So anyway, we don't want users to encounter bugs. This also makes it easier for us to extend the application in the future. Tests, I think one of the biggest benefits of testing is that when I come back to an application that I've written in the past, or when new developers are coming to a project for the first time and they don't know what the application should do, the benefit of having automated tests means that the expectations for what the app should do are explicitly written to accompany the code, so that anyone can read the test and get a good sense of what that code's supposed to do. So there's so many benefits for automated testing, and that's why I chose it as my topic. All right, thanks for bearing with me for a few minutes as I just give a high-level intro to automated testing and why we should care. So I might go back into the slides later, but I think I'm going to keep moving because I want to get into some coding. There's also some notes for you here about software testing in general and some practices and philosophies and some other quality control practices. So I'll leave you to read those, but right now I would like to turn our attention back into the repo that I've shared with you. So I was talking a little bit earlier about the setup instructions for this repo. Essentially, I'd like for you to download the repo so you have it locally on your computer, and then install the PyTest package as necessary. And then when you're ready, you can start following along. And I'm assuming some of you might be ready to start following along. And if you're going to be following along, you might reach us soon. So I'm just going to continue. All right. So after you have the app, the repo installed on your local computer, I'd like to give you a quick tour of the files and the file structure of this repo. So let's see what we've got going on here. We've got your normal README file and license. And you all are Python familiar, you know the requirements.txt file contains some packages that we can install. So you could just do pip install requirements.txt. So those files should be familiar. This is just a file that has some links in it. So that's kind of some file that I like to put in here. But and also I'm assuming you're familiar with the git ignore file. It just helps us keep secret credentials safe and ignore clutter files from our repositories. But I would like to draw your attention to a few files at this time. And then if you have questions about these other files, I'll hope to actually talk about these hidden files, PyCache and PyTest cache, like what are those about? And also this conf test file and what that's about. But where I want to go right now is into the app directory and the test directory. So sometimes you'll see a Python app and the files are all in the root directory of the repository, and that's fine, but I like to achieve a little organizational structure in my repo by separating my application code into an app folder and my test code into a test folder. But what's a test? We haven't really talked about it that much, so let's just focus right now on the application folder. In there, you'll find two files. One is a game of rock, paper, scissors. It's a command line game, and I encourage you to play it. I'll play it a few times now. We'll start in this exercise of rock, paper, scissors in the game.py file. And then our second exercise will be more of a data science related exercise where we're issuing an HTTP request to an API, getting some data back, and then parsing that response and trying to make sense of it. And so I hope that that is applicable to you, especially as you're interested in data science. You can test your data parsing and all your data science code as well. And I encourage you to do so. All right, so let's get into it. Before I get into this, you'll see additional kind of a walkthrough in the README. I'll let you go through that. I'm just gonna be interacting with you live through live coding. So if you're wondering what I'm doing at any time, you can kind of just follow along with these exercises that I've provided to you in the README of this repo. First is the game exercise. Second is the data parser exercise. So that's kind of all we've got left for the remainder of this lecture. All right, so I'm getting into it right now.
Great.
Can I have a quick time check?
Yes, you're doing fine, especially because we started a little bit late. I'm okay running 5 or 10 minutes late if you are. But I'll go ahead and throw in a quick question here, which is a sort of a good framing question from Will. He's saying, I'm sure you'll cover part of this, but my main problem with writing tests has been figuring out the right edge cases to test. Is this just something that comes with experience, or is there like a thought process we can go through while constructing tests to logic out the potential edge cases?
Edge cases, that's a really good question. Sometimes you don't know about the edge cases until a user runs into a bug, and then you add that edge case into your test suite. So in the future, no more users will run into that bug. That's how I've seen those really supreme edge cases happening sometimes. Otherwise, in general, if someone's like hounding you to work on your code very, very fast, I think it's really worthwhile to push back against that person a little bit and say, hey, I have to think about all these edge cases. I need time. And just kind of take that time, go for a walk, and try to think about those edge cases. But I hope some of what we do might also answer that question. So I think that I hope that's a
No,
reasonable
I
answer
would
to your
second
question.
all of that from my personal experience as well. I would also say that hopefully you have a culture of testing and quality in your team and with your manager, so they stand up for you with that too. But
Yeah.
of course, that will vary. And another thing you can do, if you have a large user base, you can do like slow rollouts. You can roll out to, if you're Google, rolling out to 1% is probably enough to identify lots of edge cases because
Yeah, and prevent a bug from like messing up like millions of users' experiences. I agree. Oh, can I just have a time when we should be ending, and then I'll manage?
sure. Do you think you can maybe lecture for about half an hour and then we'll transition to questions?
Oh, sure. That's more time than I thought I had. Sure.
That's perfect.
Okay, cool. So I'll aim to go until 50. Thanks. All right. So I've been kind of hyping this for a while, but let's actually get into it. And we're ready. So let's play some rock, paper, scissors, right? All right. In the README file, you'll see the command to run this game. I know a lot of you have been working in notebooks, but I hope that you're also able to execute these scripts and you're familiar with doing that. So we're just going to execute a Python command to invoke this script located in the app folder, and it's called game.py. Here we go. So importantly, from the root directory of the repository, that's where we're going to do this. So rock, paper, scissors. If anyone isn't familiar, each person chooses either rock or paper or scissors, and then people duke it out. Rock beats paper. Paper beats rock. Rock beats scissors, and scissors cuts paper. So that's who wins. So we're going to be playing a game of rock, paper, scissors against the computer. We get to choose, and then the computer choice will be random. And you can see the code that does this. We'll go into the code in a sec. So
Just,
I'll
I
choose
just
rock.
dropped a poll in the channel if anybody wants to vote for rock, paper, or scissors.
Oh, sure. Yeah,
We'll
so
give a moment to
let's,
see. Yeah, well, this will be sort of like Twitch plays.
cool.
Looks like rock is winning at 67%.
I think that's psychologically how it always happens too. All right, so we chose rock and the computer chose scissors. And so all that happened really great. But the game is saying that that's a tie, and that doesn't match my expectations of how rock, paper, scissors should be played. My expectations is that rock should beat scissors. So right now we're seeing it's a tie, and we really want to see who won. So I intentionally kind of just like gave you an unfinished product, and we'll finish it together. You could also think about this as being maybe someone tried to implement a finished version, but there's a bug in it. So it's our job right now to go try to fix this. So let's go into the code. All right, so it's a tie. No, not really a tie. So what's going on here? Let's take a look into the game.py file. So I'll just give a quick walkthrough of what is in this file. At the top, we're importing our packages and modules, and we only need the random module for this game in determining what the computer choice is. So random choice between our valid options here. That's how the computer is making their choice. If you're familiar with the input function, it asks the user for a user input and then stores the result in a variable. So that's how the user is giving their choice. This section right here is validating the user's choice. If it's an invalid choice, we're just going to stop the game so that we don't try to calculate who won out of some ridiculous mistaken choice.
It's not rock, paper, scissors, bulldozer.
No, not today.
No, not today.
But we could build in a bulldozer, yeah. So validation is very important. So user gives a choice, that choice is validated. Computer gives a choice, and then the determination happens. And here's where we need to fix. And so we'll get back into this in a sec, but after the winner is chosen, then we're just kind of conditionally printing out a message of who won. So we need to determine what that winning choice will be. And here's where I'd like to start getting into this code. I'm just going to give myself a lot of space to work. I encourage you to do this too. All right. What is the winning choice? At this point, if I'm coding up this game, I'd be tempted, and I probably would start just by maybe saying like winning choice equals rock. And so I would test the game out a few times and it wouldn't give me the right results, but I would be confident in the rest of the structure of this code to then eventually get to determining which selection is the winner. So now I'm there and I could be tempted to do all that logic right in the script itself. And we could do that and it could work. But in order to test our code, we need to test a function in isolation. So we wouldn't be able to test the logic of determining the winner if that logic was in the script itself. So for that reason, I recommend that we move that logic into its own function so that we can just focus on that one function. So here, I would probably invoke a function in the way that I wanted to use it, kind of like working backwards. I know we have a user choice. It's either rock or paper or scissors. I know we have a computer choice, either rock or paper or scissors. And we know the winning choice should be one of those, but which one? There's kind of some logic at play. So we're going to move it into its own function. And the benefit of doing this is so we can test that function in isolation. All right. So I have uncommented line 42 and set up a function up here with some docstring to tell what it should be doing. But right now it's kind of like to do. So let's see what happens if I just try to play the game with a to do as the winner. It probably will not work again. So I'll choose rock. The computer shows rock. Oh, it doesn't even say like who won. And that's because it was an unrecognized selection down here. And so you could kind of put in an else statement here, but the validation of the user choice should prevent this else statement from ever getting reached. So you could do something like this, but I just won't. And then we would see, oops, maybe I'll just put it in right now. So you'll see something like that. Rock, oops, we're just messing up. All right, so already what you've seen me do is I've kind of written some code and then I went back to the command line to manually test it out. So we're already starting to take testing actions to determine the quality of our software and determine whether or not it's doing what we hope. And those manual actions, we can observe ourselves doing over time. So what am I doing? I'm just running the game, inputting an example user input, and then seeing what the result is and asking, does that match our expectations? So another benefit of automated testing is that it can automate this process and save you all these manual steps. And so that's why we would turn to automated tests. But more about this later. I just want to get back into the logic here. Let's do part of the logic. We know that the winner logic that we need to implement says rock beats scissors, scissors beats paper, paper beats rock, and the same selections should result in a tie. And if that happens, we should return none. So I'm just going to start implementing this logic. Maybe if this is like a real application, I might not know all of how to implement the logic, but I might know the first place to start. And so that's what I'll do here. Let's start determining the winner. I'll probably say like if the user choice and the computer choice are the same, let's return none. If they're equal to each other, we'll return none. And that represents a tie. Otherwise, maybe let's just return oops still for now. oh, sorry, winner equals none, winner equals oops, and then we'll return winner. So I've started to implement this logic. I'm not done. And what I would do normally is I would try to test this out. I would run my game. I would choose like rock. We chose rock. The computer chose scissors. But we're not able to like specifically test the scenario where the computer chooses rock as well. That's what we want to test. Rock versus rock. We hope that results in a tie. So what would I have to do? I might have to rerun this app a few times, like rock, and then just hope the computer chooses rock. And maybe have to play a few times, like a lot of times. And so I'm kind of like wasting my time right now. Another approach would be to hard code the selection, and that could save us time, but then we're introducing code that isn't really part of our ultimate logic that we want to implement. So, but just to save us time in the randomness of it, of running the app through the command line, let's just hard code both choices as rock and hope to see that this works out. It doesn't matter what I put here because we've hard coded it as rock. Okay, great. And the computer selection was overridden. So we see that that's a tie. Okay, great. At this point, I'm kind of confident that my tie logic is working out, but we still need to implement the rest of the function. As you can imagine, you could just kind of update these values inside the function itself and continue to test different scenarios. But I'd like to now introduce you to how to do this explicitly and a little efficiently using tests. So right now, I'm going to leave in the logic determination that says the same choices should be a tie. And I'd like to start introducing to you how you could start automating this process of testing your app, so you don't have to hope that you catch that computer in the random selection that you're hoping to test, or so you don't have to kind of like hard code some of these values. All right, ready? So we're going to use the PyTest package to run our tests. But first, what does a test look like? I'd like to draw your attention to the test directory where there is a file called gametest.py. If you didn't have any tests set up in the first place, you could create a new file and call it something test.py. The test file, in order for PyTest to recognize it as being a test, should be named with an underscore test at the end. So I'll show you how PyTest recognizes these tests in a sec. But let's take a look at this game test. Maybe before we get into the game test, let's prepare to run tests. So back in the command line, and you could follow along with some notes in the README here. What we want to do is pip install PyTest if you haven't for the first time. And it's the PyTest package that's going to allow us to invoke tests that we've written. PyTest will also recognize which files in our repository it considers to be tests. And there's some logic, part of which I've just shared with you and part of which I'll continue sharing in a minute. But how this works is, you know that we can run the game file by invoking the Python command line utility. We can invoke our tests by running the PyTest command line utility after we install it. So the cool thing about running your test is that you should see some like color-coded output. Red usually means your test is failing. Green usually means your test is passing. Don't get too confused with this output yet, but what we see here is that PyTest, when we ran it, it recognized that we had some test files and that there were multiple scenarios or tests or assertions inside those files. And green means they passed and red means they failed. And if they failed, PyTest will tell us why they failed. But let's get into the specifics of these tests now, focusing on the game test. So at this point, you might even have a blank file, like go add a new file called game test into the test directory.
A quick question, sorry. A quick question
Sure,
came
yeah,
in about file name convention. Can you also have test underscore file name, or is it always file name underscore test?
So I will default to the official PyTest documentation. I believe that sometimes that will work. Let's actually do a test right now by renaming this file, like test game or something.
I've seen underscore test more myself, but
yeah, the convention I think I've seen more of is underscore test, but I think this will probably work too. Let's find out. So yeah, it still picked up little test. But if we just called this like do stuff with the game, let's see, then that game test didn't get picked up. So it either has to be test underscore or underscore test. Nice question. So we see that there is some rules about what you have to name these tests. All right, let me revert to what I had here. All right. So along that topic, thanks for asking that question. With that topic, there's also some convention. I'll let you read all of these notes that I left for you, but they're kind of confusing me, so I'm just going to remove them now. All right. In order to create a test function, it's just a normal function. So we can create that now, like define a new function and then call it something like, hey, something. Except your function names also, the names matter. They should be test underscore something, and that's what helps PyTest recognize that this function is a test that PyTest should run. So if we wrote a test in here, I don't think it would get triggered by PyTest or detected. So wow, I'm running really low on time. I'm just going to abbreviate this demo, but I think we're fine because we got the I'm going over the high level concepts. Anyway, let's finish why I got us in this test file is to automate those manual processes that we were doing. One thing we definitely want to do is directly invoke the function that we want to test. In this case, our function is coming from our game.py file, and it's called determine the winner. So from our test file, we'll import that. Since we're low on time, this is a great time for me to mention that the special file called conf test in the repository's root directory serves the function of saying, hey, PyTest, consider wherever the conftest.py file is, consider that to be like the root directory. And then, so it helps your import statements like app.game. It helps reach into some of those other folders. But anyway, so we're going to import that function, and we'll use a special keyword inside our test function called assert. Essentially what it does is it says we evaluate something to be true or false. So a simple assertion could be assert true. So now if I run that test, oh, by the way, you could also run specific tests by passing their file name. So instead of running all the tests like I was just doing with PyTest, you could give it the name of the test that you want. So right now that is failing because we said assert false. If we said, oh shoot, what? What? Oh, this is do stuff with the game? Not cool, not cool, not cool. Wrong file. Oops. All right, all right. Let's try this. Hey, assert true? Yeah. Test pass. Assert false. Test fail. So, but we want to invoke directly the function we're trying to test. So in this case, I'll assert that when rock plays rock, we hope that the result will be none. That's our expected behavior. So with that assertion in place, let's test it out. Test pass, sweet. Normally what you want to do is make sure your tests fail first and then implement the logic and then see the test pass. So then you know it's because of what you just implemented. That's a pattern called red light, green light refactor. More about that later. Anyway, I'm done with that logic and that test is passing, but I know that when rock plays paper, paper should win. So I'm just now adding these edge cases, I guess, or different scenarios that are possible to be tested. Now we see that test failed. So now it's up for me to go implement the logic in the test file itself. And so like a cooking show, I'm just gonna reach into some pre-completed code. And if you're interested in this, I'll share it with you later. It turns out like there's an efficient way to do this just using a dictionary, something like this. I'll share this code with you later. I'm running up against time. Sorry about that. So now, hopefully, after implementing all the logic and specifying all of our test cases that we hope to test, eventually we get to a scenario where our test passed. And yeah, we are more confident now that our game's working. Wow, it took me a while to go through that game exercise. I'm sure a number of you are really bored by now, I'm sorry. But I talked about some of the things that I wanted to talk about in there. Are there any questions right now before I talk about one topic about the next
there's a few
exercise?
general
We won't be
questions.
able to get into the next exercise, but yeah, I'll take questions now for sure.
All right, so would it be realistic to stick exclusively with PyTest for continuous integration with production pipelines, or should we expect to need multiple testing frameworks for deployment?
Okay, you can use PyTest with continuous integration. I usually use Travis CI, and there's links that I could share with you. Let's see if any of them happen to be up right now. There is one in this. You'll find these links in the credits file in the repo that I shared with you. But here's an example of how you would integrate with CI. For example, to prevent HTTP requests from being made on your CI server or anything like that. Let's see. So on CI servers, there's environment variables set up like CI equals true, or they each have their own kind of environment variables, or you can set your own on the CI server, like CI equals true. And so when your tests run on the CI server, you can skip some of them by using PyTest internal logic, like this example that I'm showing you. And so PyTest in this way is able to integrate with CI, and you can do some skipping of tests and stuff like that. Anyway, I hope I answered your question.
Yeah, and one more quick question. Does the test run through all potential responses, or what exactly does running the test do? And I think it's like specifically the test you were showing.
Yeah. What does running the test do? When we run PyTest, it collects all of the test functions, and then it separately evaluates all the different assertions inside. Sometimes you'll hear that it's a best practice to only have one assertion per test function. I don't think that's a hard rule, but essentially what each assertion will do is it's in this case specifically is that we've loaded this function that we wish to test, and here we're actually invoking that function as if we were to have, for example, implemented a breakpoint here. Oh, actually, no, a breakpoint in our main script. So right here, here's where our main script is invoking that function using some wild parameters. We're invoking that function with some specific parameters in a controlled scenario to make sure that given those specific parameter inputs, a specific parameter comes out. So PyTest will invoke this function with these specific inputs, see what it outputs, and then when the assert keyword here will just designate whether that test is passing or failing. I hope that answers your question.
Great, yeah, I think so. And if you want to cover a bit more, I mean, we still have time.
I'll just go over a high level how this can be helpful when you're working with APIs. So I won't get into the answers for this next parser exercise. You'll see in the repo that I shared with you, there was a game exercise and a parser exercise. So it's the parser exercise that I'll be talking about now. If you want to follow along, you can install these packages. We'll just be making a request to some API. And if I knew that, so I want to talk to you at a high level about my workflow here. If I knew I was going to be making a request to an API and trying to do something with that data, let's take a look at the parser file, parser.py. You'll find I put an example link to like a URL request, an API request, excuse me, that we can make. Normally, when I'm working with an API, as many of you do when you work with data and you get data from the internet, I find that it's important to inspect the structure of the response. And if we're able to do that in a browser, that's great. So what I've done here is I've made a request for this URL, this API URL in my browser, and I see what kind of data comes back. And if our goal here is to write some code to return the latest closing price, for example, based on this data, you would imagine that it's possible for us to, while we're iteratively developing some code that's going to make a request to this data source and get this data back and then try to work with it, while we're iteratively developing, we will probably need multiple iterations to get that code just right. But while that's happening, if we're just kind of coding in the wild, making this HTTP request, with each iteration of us kind of testing out this code, we're also making an HTTP request. And those HTTP requests, while you're developing, I would say are unnecessary. They're placing an undue burden on the API server and an undue burden on your own computer in terms of its processing power. But you might most often run into this issue if you're working on your hotspot, like a mobile hotspot, for example. You don't want to keep making requests and ruining your data for the month. So you can use automated testing to essentially use a mock version of this data structure in your tests. And I've written some notes about that in the parser test file. But essentially what you could do is move that data structure into your test directory as like an example JSON file. And then within your test, for example, the parser test, you could read the data from the JSON file as you test out the logic that you're trying to test. Or you could represent that data more simply in an abbreviated mock structure like this one, which only has 3 days worth of data. And so I'm able to run this test latest closing price with this example data. Hey, does my function get the latest closing price given some example data? Does it give me the desired result? By running the test, I'm almost done here. Thanks for bearing with me. The parser test. By running this test, right now I'm not issuing any HTTP requests, but I am evaluating whether my logic works as expected. So going back to the cooking part of the show, I'm just going to shoot. Revert to some completed version that I have. Oh no, I lost it. Anyway, I have the completed version right here. So, or I had it up. But basically, now I'm able to implement some code to do what I want in my parser file without issuing any HTTP requests. So this is the function we're trying to test. Right now, it's just saying, hey, the latest close is 100, but that's not right. It's really going to be based on the data we pass in. So eventually, as we're iteratively developing, we would be, implementing this code to get the latest closing price. And eventually, we would get here. And we can get here a lot faster and a lot more responsibly by using test-driven development, such that now when I run this PyTest, the parser test, hopefully this test will pass. Cool, now the test passes where it didn't before, and I haven't issued any new HTTP requests. And one of the most important benefits, this is my final point, thank you. The most important benefit of doing this, I think, is in collaboration with other developers and with yourself across time. How do you know like what some API response is supposed to look like when you come back to some app months later? If you have saved a version of that response in some JSON file, for example, you'll know exactly what to expect. And if the API changes, you could just update your mock data to reflect what those changes are. And so you can stay alongside the API changes like that too. So tests, zooming back out, they're good for, they are good for quality control purposes, user experience, preventing bugs, but also I think tests and automated tests specifically are really important to a collaborative process on and enabling collaboration on a code base. They can help other developers understand what the application is supposed to do, and they can help you over time, like months or years later, understand what the app is supposed to do. And it can help developers more quickly get up and running and started with an application. In addition to that, like you saw with our rock, paper, scissors example, automated tests can help us determine whether or not some isolated pieces of our overall application are working. And so by testing all of the isolated pieces, we'll have a better overall confidence that everything's working as expected. But well, actually, that's how I'll leave it. All right. So
Great.
If there are any more questions, I'd be happy to take those, but I don't know if we're running up against
No,
time.
I mean, there are a few questions that come in, and since we started a few minutes late, if you're okay with staying a few minutes past the hour, we can hang out a little bit extra. So, but thank you so much, and I also want to say that a lot of this presentation has echoed my personal industry experience as well. I'll leave it at that
Cool.
because I'm not the one presenting, but yes, tests really matter. So it's great to get a presentation focused on them. So the main, I'm going to have to paraphrase this because it's less of a question and more of like 3 or 4 people having a discussion at this point.
Okay.
But
I hope it's positive.
no, it's positive. So it started with Will asking, mocking an API seems like it can easily cause your test to become stale unless the API never changes. Is there a way to test APIs so you know automatically if the API changed when you run your test? And you kind of talked about this a little bit, and then people are like, well, shouldn't APIs not really change? Well, I've used undocumented APIs, et cetera, et cetera. So what's your take on the wide, wonderful world of untamed APIs?
Okay, so I forgot to mention at the top that my favorite or my most prevalent language that I've been working with is actually Ruby and Ruby on Rails and the testing framework called RSpec there. And there is, and actually this might go cross languages. I've just never used it in Python, but there's this concept of like cassettes and VCR in terms, okay, so what I prefer is to hard code what my expectations for the responses are and periodically update them. Usually, if the API you're working with is responsible, they'll send you an email saying, hey, we made some breaking changes. You have like X months to fix your code. And so that would give you the time to hopefully update your test and run against the new version of their API. But if you wanted to try to go more dynamic than that, there are some packages that are worth exploring. I know that some of them are, one is called like VCR or something, and I'm talking now from my Ruby memory, but what it will do is it will make a real live request to some URL that you specify, and it will store that data automatically in a mock JSON file or something like that. And so that could be fine too. My experience with working with those, however, is that sometimes they just changed, like the headers would change, and I don't know, it was kind of, I think it was more complicated than I was looking for, than I needed. And so for me, especially like having that mock JSON on hand is really helpful. Anyway, I hope I answered that question.
No, definitely.
Hopefully, I think the answer is like, hopefully the API you're working with will give you advance notice about breaking changes to give you time to update your code.
Absolutely. So, and I do think that it is subjective, but in general, having tests focused on testing one thing well is another good sort of philosophical reason. There are people linking like Postman, and there are other tools out there that let you test making requests. But another thing to know about test is once you have your beautiful CI set up, every single time any developer on your team makes a commit and pushes it is going to trigger the test suite. And that might be a lot of requests, and eventually your API service might not appreciate that. So
Yeah, the ultimate goal for speed and optimization is to prevent network requests from your tests. When I'm kind of introducing testing with my students, and to be honest, when I started out with testing, I introduced live requests into my test, and that gave me a good sense in terms of like an integration test end to end. Yeah, like the data that I get back from that API is really going to work with the rest of my program. And so I don't think that's the worst thing. I think I would prefer seeing presence of tests that make those HTTP requests than absence of tests. So my message that hopefully you take home is that presence of tests are very helpful. Oh, but also tests are for your benefit. So you saw us doing some manual, testing, and that was taking us time with those rock, paper, scissors. The goal in automated testing is notice what manual actions you're taking. Like a lot of times I'm testing my code and I'm like, what is the data type of this variable? What are the keys of this dictionary? And so when I might do some like print statements in my code for my awareness, but in the end result of the code, like we'll probably have to remove those print statements. But I can now observe that the function of those print statements were to help me understand what was going on. And so if you see yourself like printing things out, those are generally good candidates to move into a test. Anyway, okay, thanks for letting me add that note.
no, that's great. And yeah, I think also, as you highlighted, there are different sorts of tests. And so it does make sense in some situations to have something like a true end-to-end test that maybe does a lot of stuff, but that's not necessarily the one you're firing off all the time. Any other questions coming in? Going once. Going twice. All right, people are thanking you, and people are already very excited with all that great stuff in the repo you shared. There's more there to dig in, so please,
Oh
everybody,
yeah.
checking it out.
Oh yes. A final repo that might be interesting for people is at the bottom of the README of um, the repo that I shared with you. There's a link to this Omni parser exercise. So if you're interested in data parsing, there's some tests set up in there already, and they're failing. And your goal is to parse the data to make those tests pass. Might be fun for you. Okay, thanks for giving me that parting note.
Great. No, that's a great party note, and it, being able to test parsers and I mean, you are absolutely right. Hidden APIs is important. Many of our students are working on stuff with that right now. So, thank you so much, and thank you everybody. Take a little bit of a break from your screen, and then make sure to work on your afternoon assignment. Thanks,
Thanks
everybody.
everyone.